Welcome everyone to this week's CERIAS seminar. It's a pleasure to have Christopher Nuland from Red Hat, no? I see in your slides, Cloud Native. So Cloud Native, you're going to tell us about it. Christopher is in Red Hat. He's an expert in container technology, has worked on securing cloud native applications for several Fortune 100 companies. And he was also at CDM Hub at Purdue for a while. So it's great to have you back to tell us about what you've been up to.
Thank you. Yeah, as mentioned, my name is Christopher Nuland. Today, I am going to be talking to you about enhancing software supply chain security in distributed systems. Sorry about that. I pressed the wrong button. Just a little bit about myself. I've been with Red Hat now for going over 5 years. The first few years that I was at Red Hat, I specialized in large-scale migrations and modernization. So most of this was with large Fortune 500 companies like ExxonMobil, Ford, Anthem Health, as they started to take their legacy applications and move those into the cloud. I got my start actually in this area at Purdue. So I'll talk here in a minute about some of my Purdue experiences, but I got involved in container technology very early on. This is pre-Docker, doing some work with the Department of Energy. And that spun up to where I'm at now here at Red Hat. So I've been riding that wave of cloud native migrations over the last 10, 15 years. I'm also, I'm at Red Hat. So Red Hat, some of you may know, is an open source company. They're very involved with the Linux Foundation and also the Cloud Native Computing Foundation. The CNCF is part of the Linux Foundation. It's a spin-off of it that focuses specifically on technologies focused on being cloud native. So things like Kubernetes is probably the most known technology that's within the CNCF Foundation. I'll be talking a little bit more about some of those technologies here a little bit later. I'm also a speaker, so I get to travel the world talking about subjects like cloud native migrations, different areas of compliance, and zero trust supply chains. So I've had the pleasure to speak at places like Amsterdam and Valencia. Last year, I was in Detroit and Chicago. This year, Boston. And this ability to meet people like yourself and be able to speak about what I'm really passionate about is probably what I love the most about my job. So I'm also a Boilermaker. So I graduated from Purdue University back in 2012. I was one of the second or third class in the Lawson building. So it was a pretty new building when I was there. I was also the first class to have a specialty focus. So before me, everyone just had a generic computer science degree. I was one of the first groups to be able to actually specialize in certain areas for my undergraduate. And during that time, I focused specifically around security and systems. I had some opportunities to do some research with Dr. Zhu and Dr. Patino while I was there at Purdue. Some of that research then spun off to me being involved with NanoHub and CDM Hub. So for those of you that aren't aware, that is actually a container platform that was developed by Purdue, I think even going back about 20 years now. So Purdue was at the very forefront of container technology, even before we started seeing a lot of the stuff with the cloud revolution and a lot of the things, a lot of development through technologies like Docker. I ended up actually starting a company with the Department of Energy funding it, based off of the technology coming out of Hub Zero, which was the open source version of NanoHub. So I was involved with that for about 3 years, and just tons of awesome experience. It was great being here in West Lafayette in the research park, working with different professors and different people in the industry to advance some of the work that's being done at the DOE. And a little bit about myself now, I'm also the board president of the Science Alumni Board. So for any of you graduate students, we're also taking submissions for people to be on the board. So if anyone's graduating, if you're an undergraduate graduating soon or already a graduate student, we are interested in new board members. So feel free to ping me on the side about that. A bit of an outline of what we'll be talking about today. I'm going to talk a little bit about the technologies that I work with and what specifically it means to be cloud native, and just kind of building up, making sure that everyone knows the different technologies that then play a big role in some of these solutions and issues that I'm going to be highlighting. I'm going to talk about what it means to be a software supply chain and what goes into that supply chain. I'm going to talk a little bit about SolarWinds Hack that I think many of you probably have heard about. I'm going to dive into the specifics of how that attack happened and why software supply chain is so important. I'm going to talk a little bit about the aftermath and some of the policies that have come since then from things like NIST and some other federal organizations. And then I'll talk a little bit about the solutions that I develop day to day for my customers and how we implement things like zero trust supply chains and some of the tools that go into that. And then lastly, I'll show a little bit of a demo of what that technology looks like in action. So what is cloud native? This is a definition from the Cloud Native Computing Foundation, and that just simply states that cloud native technologies empower organizations to build and run scalable applications in modern, dynamic environments, such as public, private, and hybrid clouds. These technologies enable loosely coupled systems that are resilient, manageable, and observable, combined with robust automation that they allow engineers to make high-impact changes frequently and predictably with minimal toil. Some keywords here are things like scalable and then also loosely coupled. So these are two terms that are very often used in my day-to-day work that I'll talk a little bit about here in a moment. So one of the key technologies in the cloud is this concept of containers. Containers are a form of virtualization. I don't know how familiar you are with the different types of virtualization, but many of you have probably heard about VMware. So VMware creates traditional type 1 hypervisors, which create VMs. Each of these virtual machines have their own kernel and are functioning independently from their host, other than the host providing that hypervisor that spins up the virtual machine. These were very popular in the early to mid 2000s, still popular today, but as companies are moving more away from traditional data center models and moving more into the cloud, you're finding more and more organizations moving away from this traditional model. A container instead is something that shares resources with and a kernel with its host, which I'll talk a little bit more here in a second. Some of the advantages of this is that the footprint is much smaller from all resource aspects, so things like storage, CPU, memory, and then they're significantly faster to bring up. So a traditional VM can take basically limited to whatever operating system is running on that VM and all the overhead for that. So sometimes you can see VMs taking a minute, 2, 3 to run, and that's just not acceptable in today's cloud native world. And here I outline the technical architecture between traditional virtualization and containers. As I was mentioning before, a traditional VM is going to have a guest operating system within the VM, and then those applications are going to be built on top of it. The advantage of containers is that containers are actually sharing runtime and a kernel with the host operating system. This makes them much lighter and their footprint much smaller than what you deal with from a traditional virtualization. This is important in the cloud because in the cloud, as I was highlighting in that quote earlier, scalability is key, something we call elasticity. How much can we scale out an application? Some large Fortune 500 companies I work with can scale applications out to 100, 200 instances plus very often. An example I always give is for a retail store on Black Friday. They may only want a few instances of some back-end system that processes sales, but on 1 or 2 days a year, they need to scale that out to times 100 what they have currently. With traditional virtualization, that's extremely difficult. With container technology, it's just a press of a few buttons, and then now you're scaled out and being able to handle that load, and then able to scale down and not paying additional money for those additional resources that are not being used. So next, I want to talk about Kubernetes. Kubernetes is, I would say, probably the hottest technology right now from an industry standpoint. This is where I do a lot of my day-to-day work. A lot of people say Kubernetes is the new Linux, even though, funny enough, it's built on top of Linux. But Kubernetes is a container platform. And one of the key aspects here is that it's distributed. So that means, at minimum, a Kubernetes platform has 3 instances to distribute over. So in the cloud, an example would be AZ zones. So these are different availability zones that are have some ability to be mutually exclusive from each other. So like if an event happened at one data center AZ zone, it wouldn't impact the second AZ zone or the third. So typically we have Kubernetes deployed in the cloud, and we span over multiple availability zones to create that what we call high availability. We want to guarantee that things are up at all times. And just because something that affects one data center won't then affect the other data center. As I was talking about, elasticity also is important here when we're scaling. We may have only 1, 2 instances of an application running, or we may need hundreds of instances. Those are going up and down at all times based off of the demand that, that their application is under. And then from an ecosystem perspective, there are a lot of additional services built around Kubernetes. Similar to how you have different software for your iPhone on an app store, or how you have different package managers for Linux. We have the same thing for Kubernetes. We call these typically operators. And these operators bring in additional resources that deploy things like databases. They can add different logging stacks, different types of monitoring tools and security tools. Right now, the CNCF is tracking, I believe, over 300 different projects that are deploying into Kubernetes-based platforms. So, and a lot of those are in the area of security and compliance as well. It's probably the biggest market share of different operators right now that you can deploy into Kubernetes. This is a typical architecture of what Kubernetes looks like. At the top, you'll see this concept of a master node. There are typically 3 of those, just to make sure that there is a high availability. And those are what contain an API server that then is communicating down to the different worker nodes. In this example, you see 3 worker nodes. You're not limited to 3. I have customers that run 3. I have customers that have run thousands of different nodes. It just depends on how your digital footprint is and how you want to configure your applications within your Kubernetes ecosystem. But another terminology that's important is when we talk about Kubernetes, we typically talk about a pod. A pod is something that contains one or many containers. It's usually one container that's doing some primary function, and then maybe some subset of what we call sidecar containers. These might be containers that are doing some form of monitoring, or maybe they are forwarding logs off to something like some type of logging aggregate. Yeah, there's all kinds of things that we can do with pods, but typically you'll see either one-to-one or one pod having maybe two at most containers. So that's an important concept in the Kubernetes ecosystem. In this example here, you see that it's running Docker as its container image. There's a few different container platforms out there. The one that Red Hat develops is what's called Podman, and it does all the same functionality that Docker does, just a difference of opinion on how their container engine works. So that's a high level. Just know that Kubernetes is distributed. It's meant to go across different clouds, and that it's all about scaling applications out and in based off of demand. I'm guessing this is probably an overview for most people here, but I just want to make sure that when we're going into the next section that we're all at the same level from knowledge. So I want to talk a little bit about what is CICD. So CICD is continuous integration and continuous delivery. Sometimes the D can also be for continuous deployment, depending on what kind of methodology you're taking within your CICD approach. But at the end of the day, the main focus for CICD is the ability to package your applications and run any type of services that you need to off those applications. So things like security scanning, testing, all of this is incorporated into what we call continuous integration. Continuous delivery then is the ability to then deploy those applications into different environments in an automated way. So typically in enterprise situations, you'll have normally on 3 or 4 environments. You'll have like a development environment, you'll have like a staging environment, and then you'll have a production environment. So production is what your customers are hitting, and that's where you want to have the largest amount of security focus and SLAs to enforce those security procedures. But then things like development may be more of a sandbox where developers have a little bit more control day to day of what those configurations look like. And here's an example of what one of those pipelines looks like. This is an example of something called Openshift Pipelines, which is based off of the open source technology called Tekton, which I'll be talking a little bit about here towards the end of this presentation. But the idea is the same across all technologies. You're typically cloning some code from some type of repository like Git, and then you're running a series of procedures off of that code. In this case, there's different types of tests that are happening, and also scanning that's happening on that image and that code to make sure it's secure and it's not bringing in any vulnerabilities. Lastly, then you have deployment going into some type of environment, in this case, more than likely a Kubernetes environment. And then afterwards, you have some type of testing happening off of that live application, a canary test, making sure it's up and running, and then making sure that there's no vulnerabilities being exposed from the application when it's running live. So this is an example of a typical CI/CD process that we'll see out in the wild. I want to talk a little bit about supply chain as well, because this is going to be important for the example that I'm going to be given. And supply chain is not anything specific to software. Actually, terminology was very commonly used for manufacturing. So what is your supply chain? What are the different types of materials being used? What are the production costs? What types of engineers are involved with the assembly facilities? And then towards the end, like the sale of a product, and then what's the life cycle after that? The support of that product and the logistics. This is what's typically called a supply chain. And especially in the public sector and like the defense, especially, supply chain is very important because you want to know where everything came from. So if you're building a microchip, you want to make sure that a hostile nation isn't the one that built that chip and then sold it to another company that then built another component, which is then adding a threat into your whole supply chain. So these types of things I'm going to talk about today, a lot of the ideas actually came from manufacturing, and we'll talk a little bit more about that here in a moment. But just know that this is not exclusive to software. An example of what that could look like here is you have engineers designing a product. You have then an assembly line. Then you have different types of logistics where trucks are delivering that to different retailers, and then those retailers are ultimately selling it. So this is an example of what the supply chain can look like in manufacturing. Now for software, it looks a little bit different, but some of the same concepts apply. We talked about CICD a minute ago, and a lot of that will be centered around that build section here in the middle. So a lot of the steps that you saw there are in that process. But if you're talking about the complete supply chain, that goes all the way to actually the developers writing code, designing different components within their software, and then making sure that that software meets certain quality checks before then building that code and releasing it. You'll also see on the right side, you'll see a monitoring section. Well, this is for all the code that has now gone into production, but we want to make sure that it's functioning appropriately. We want to make sure there's no significant errors or any resource issues or anything that we would need to respond quickly to that could prevent any type of major outage for our applications. There's a lot that goes into this too. So like when we're talking about materials for the area of manufacturing, well, there's a lot of source and dependencies now that we need to talk about when we talk about software. So you'll see all the way on the left side of this, things like application libraries, images, runtimes. These are all the things that get pulled in to make your code work. And this is often where we find attack vectors show if things aren't configured and monitored appropriately. So this is an example of what a software supply chain looks like in today's industry. I want to talk a little bit about the SolarWinds Hack. I have a feeling a lot of you are already familiar with this, but I want to touch on it because this is where a lot of the urgency has come from today in industry around trusted supply chains. And this is not a all-encompassing case study. I'm going to be glossing over quite a bit and then targeting one area specifically. But just know that there's a lot of nuances to this attack. It is probably the most sophisticated attack and hack that we've seen in history. And there's a lot of different variations and steps that were taken for these bad actors to actually implement what they did. So I highly recommend, if you don't know more about this afterwards, go to YouTube, just search SolarWinds Hack. There's a few actual like documentaries, like short documentaries that you can watch actually outlining all of what happened and all the political fallout from it. So it's a very important thing in industry. It comes up a lot in my conversations with clients. And this case study is something that just is referenced consistently when it comes to compliance. So what is SolarWinds? SolarWinds is a monitoring tool. It is primarily used to monitor customers' networking and infrastructure. So it does a variety of different things. It's looking for bad actors. It's looking for any anomalies in network or any anomalies in configuration that would notify a company or an agency of a potential threat. So this already means that they are embedded in quite a few high stakes areas. And one of the key aspects here is that given the type of application that this is, it had a lot of access and privileges over these customers' systems, typically having the highest access. Mostly they thought they were protected through just a variety of different aspects of the system itself. But if you got through to the very end of that, in this case, supply chain, you could then take over pretty much anyone's system, having full access. So this was what amplified this situation, and probably was one of the reasons why it was so heavily targeted based off of its clientele and because of the type of tool and access it has within a customer's infrastructure. They also have a large footprint, like I said, a variety of different customers, Fortune 500, a majority of Fortune 500, and then also a majority of different US public sectors, so Department of Defense, energy, and so on. I'll talk a little bit more about some of those here in a minute too. One of the big aspects of this attack was just the time frame. A lot of times attacks happen within a short period of time, or even if a bad actor is casing a particular organization, you'll see that usually happen over a month, 2, 3. This one, it appears like it went back at least 2 years, potentially even more. So just to show the level of sophistication in this attack, there was a lot of planning here. There was a lot of steps that they took, and a lot of careful planning that they did to be able to deploy all the different elements of this attack. There's, I think, 5 critical points in this. So you'll see things like sunburst, and then I think there's a few others, variations of different malware and tools that they deployed. I'm not going to go too much into those right now, but if you do have opportunity to go and do some research, because this whole scenario is just amazing. It really changed the industry, and it's going to affect really all of technology for years to come. But just know that this is something that happened over a couple of years. And then the critical part here is there on 11/4/19, where they were testing code and injecting different code into the packaging, or rather the CICD process supply chain that I was talking about earlier. And that's where this was able to then affect a lot of different other people. This type of attack is what's called a supply chain attack. And this is going to look very similar to what I showed earlier with the CICD process. We have some code, we're going to build that code, we're going to deploy it, and then we're going to allow customers to consume those variety of different endpoints that are available to the software or whatever process is being run. In this case, a bad actor has taken over the build process, either by the source code or through the build process itself, and then starts injecting bad code or different types of malware into the legitimate code that then gets pushed out to your end users. The reason why this is so devastating for SolarWinds is because this is an update that got pushed out to 18,000 different customers over the world. And if it hadn't been caught as quickly as it did, its potential impact was up to 300,000 instances across the world. So it was a good thing that it was caught as quickly as it was, or the blast radius of the impact would be massive, even compared to what did happen. But once this bad code has been infiltrated, that allows then the attacker to then communicate with that software once it's gone live in some type of production environment that then can communicate back and send sensitive information back to the attacking group. This is a quote from the Microsoft CEO. The attack on governmental organizations and businesses using the SolarWinds software is the largest and most sophisticated attack ever. And as I said, if you get opportunity, definitely go check this out. There's more nuances than what I was just showing. The supply chain attack was probably the most critical part of this and what I'm going to be highlighting today. But there was a lot of different other steps that were used to get to the point that that attack vector was available to them. So the impact, as I mentioned, over 18,000 instances of SolarWinds were known to be infected with this backdoor software. A lot of these included different Fortune 500 companies like Intel, NVIDIA, Cisco, and VMware, and then different government agencies like the Treasury, Commerce, State, and Energy. One of the biggest areas was energy in particular, because the Department of Energy is over the US nuclear arsenal. A lot of people believe that this particular agency was one of the top that they were trying to target, and knew that SolarWinds had contracts with. A funny thing about this too, before this attack, SolarWinds had a list of all the companies and government agencies that they worked with. They think that this was actually part of the approach that these attackers took, that they were able to see, oh, hey, the Department of Energy is here, the Treasury is here, NVIDIA, all these big companies and agencies pushed it up to being a real attack target. Now there's encouragement to not display these if you are a company in the security area, because you don't want to give this off to a potential bad actor. You want to be, promote your business, but don't promote who your customers are to create that type of attack vector to them. So a little bit about the aftermath. In one of the more recent NIST, so if anyone doesn't know, NIST is the body that comes up with a lot of different standards. They are the body, US agency that typically these standards then percolate down to different compliance standards. So things like different requirements for applications that are being built that could have sensitive information, like different types of encryption that's not allowed to be deployed to different countries, for example, or HIPAA, for example, and healthcare, or some of the different financial service compliance restrictions. A lot of them will pull down from NIST. So when NIST comes up with a new standard, the whole industry is looking, because it's usually the benchmark that then gets set for all the other industries at that point. So within NIST 800, I'm not going to go too deep in this, but the main focus is around this software supply chains, and how do we create zero trust supply chains. A lot of it centers around how do we verify that applications are coming from where they're supposed to be, and how we verify also what's called a bill of materials. So that just means the whole process, the supply chain process, was what you were expecting, and that nothing has been inserted into the process along the way. So if you are really interested in what industry is doing right now with around these requirements, definitely take a look at that particular NIST 800-218, because a lot of these standards came out in that particular release. Since then, we also have the supply chain levels for software artifacts, or the SLSA. This is a framework that was built mainly by Google, but also from input from other companies like Intel and the Linux Foundation. And it's what then outlines different software tools that you can use, especially in a cloud-native environment, to make sure that you're meeting the NIST 800-218 standards and the standards for securing supply chains. So they take what was in the NIST document and they break it down into more of language that would be understood by software developers. So if you're wanting to know more about some of those standards, I highly recommend checking the SLSA Very often when I'm dealing with clients these days, being SLSA is compliant is very important, especially right now in healthcare and finance, while we're coming up with these zero trust type of supply chains. So I'm going to talk a little bit about the solution. A buzzword in the industry right now is it's called Devsecops. Before this, DevOps was a big buzzword, and different people have different ideas of what that word means, especially since it was a buzzword. But overall, it just means that a methodology or a person or a technology that is bringing together your development and your operations. So operations over here would be people who are maintaining your servers and hard drives and networks. And over here, you have your developers who are writing code. And then in between, you have what we call DevOps. Like I said, that can either be a methodology, that could be a person doing DevOps or a team of DevOps, or it could be a tool like a lot of the CICD tools are often called DevOps tools, because they're what bringing the code and bringing it out to operations, which is your servers, your cloud infrastructure, from there. This new buzzword came out especially after this SolarWinds hack, and that's DevSecOps. And the NIST 800 focuses a lot on the concepts that are put in here, and that is we need to come up with as much automation as possible with security to handle the software lifecycle process. Because a foundational point of computer security is that more often than not, human error is what's contributing to an attack vector, less so than code error. So as much as we can do to automate these processes, not only does that benefit from a security standpoint, that it reduces the potential amount of exposure, but it also allows security specialists to focus on other aspects. It allows them to focus on research, allows them to focus on how to improve their organization rather than having to do security reviews of code or security reviews of releases. So DevSecOps is probably the hot word right now. Just like any buzzword, it's going to mean something different to everyone, but just know that ultimately it's about incorporating security into the supply chain process, and how do we do that in the most automated way possible. Now, in this diagram, you'll see it's very similar to the one I shared earlier, but I want to highlight a few areas. And that's going to be, let's start here with the rootless image build. The idea here is that in this example, we know that the image that we're using, we know the source of it. In this case, rootless just means it doesn't have root access to the system. It has different types of access controls in place to prevent it from being able to create a parallel attack vector. And it, it's been verified that the developers, that's their code that they're pushing. After this point, we have here what's called store and sign image. And this is where most of my work day-to-day has been over the last probably year and a half. The idea here is that every asset that you create, an artifact along this process in the supply chain, you have some type of receipt. And in computer science terms, we would call that a signature, some type of hash that's being created off of that artifact to make sure that we can verify that it came from the source that we say it's coming from. There's a lot of different technologies wrapped up in this. The cool part is I found out while I was researching this that actually Purdue University is heavily involved with the open source community and Sigstore, which I'll talk about here in a moment. And just know that there's a lot of different components that make up the different tools that do these type of signing. I'll talk about here in the next slide, but I just wanted to highlight there's quite a few moving parts to this. But ultimately, the idea is you're getting a receipt for every artifact that you're creating, And then before a production release, you can then go back and verify, yes, did this come from this source? Did this come from this source? And what's interesting here is that we're not just signing artifacts in the sense of like an image or a build or like a WAR file or a jar file. We're also signing deployments as well. This is very handy, especially in Kubernetes where everything is infrastructure as code. The example that I'm going to be showing you here in a bit, it actually signs that infrastructure as code that's within Kubernetes, and also says, yes, at this time, we permitted the build of this particular image using these particular artifacts, and here's your signature for verification if you need to verify at some point. What's important here in this step too is that here, once we promote to prod, there's a verification step that'll then go and make sure that, hey, are all the receipts here then matching what I'm expecting? Make sure that all these things were built along this supply chain. Nothing was injected along the way, as we saw with the SolarWinds attack. So this is what we would call, some people call part of DevSecOps. In my industry, we call this a zero trust supply chain, making sure that we have every step along the way accounted for and that we know where every artifact came in along the way. One thing that I want to highlight that's not in this image is that all the dependencies that get pulled in externally, that is a big part also of having a secure supply chain. So knowing where all of your open source tools are coming from, knowing where your own internal dependencies are getting pulled from, making sure that that doesn't open up an attack vector as well, which is probably one of the most common. So you need to make sure that you're having signing signatures off of those as well to make sure that you're pulling in the dependencies that you were expecting and not have a man-in-the-middle situation where someone's injecting another piece of code from an external dependency. The most popular community right now around this concept of signing and storing signatures is Sigstore. This is what I was actually talking about earlier, where I was on their site today and I saw that Purdue University is actually a sponsor of this community. I was really excited about that. My company, Red Hat, was one of the main companies to spin this up as well. And then from input from people like Google and some other well-known companies. But the idea being this is an open source tool that organizations can use to securely store these types of signatures and also have a way of signing those signatures and having a way to also verify then those signatures. I'm not going to go into the nuts and bolts of those, but definitely check out the Sigstore website. And it goes more in depth of the different technologies used to accomplish those signings and the different patterns that you can use, and also how it can be used out in the wild in things like Kubernetes or Linux or really any system or platform that's being run today. Tecton chains. So I mentioned Openshift pipelines earlier as a CICD tool. The upstream of that, so upstream is a term that we use to say the open source version. So for Red Hat, we sell open source applications and open source software. So typically we have our own versions of the open source that we support. And then there's some type of upstream community, and that's where other organizations and individuals are contributing to that software. So Tecton is the primary CICD tool for Kubernetes. It's what we call a first-class citizen. It means everything about it is infrastructure as code, and none of it is abstracted away behind any miscellaneous configurations. And Tecton Chains is a recent extension of Tecton, and this is the tool that does all the signing. It signs the images that are being created, and it signs the different deployments of that artifact into the different environments. So if you're deploying to a prod or a dev, you also have a receipt for those deployments. And I'll show a demo of that here shortly. But just know that Tecton Chains is for, and especially for Kubernetes, is the way that we do a lot of the signing right now. It's probably the technology that people are using the most in my area of distributed systems. Lastly, there's Kyverno. I've talked a little bit about tools for storing and creating signatures. I've talked about the tools that then apply those signatures to different assets and different artifacts along the way. But there needs to be something that enforces those enforces all those signatures, especially when you're deploying into a Kubernetes environment. Kyverno is what's called a policy engine. A policy engine is just a set of rules that says you need to have this particular label associated with your resources, or you need to have your organization's name somewhere in the name of your artifacts to make sure that we can bill back or we can, do correct support. Kyverno also has different tools for verifying signatures as well. So it'll go and say, oh, I have an image that I'm deploying into this Kubernetes cluster. I need to go and make sure that its signature matches the signature that I have, the private signature, and make sure that that is a valid match before deploying this application. So this is just another gate in that whole process of verifying your supply chain along all the different steps. This is an example of what Kubernetes is using, but there are other tools out there that will enforce the very same thing for like a Red Hat Linux operating system, or even in Windows, there's some tools that will do some of this enforcement as well. So, but like I said, this is day-to-day what I'm using because I do a lot of Kubernetes work, and Kyverno is the policy engine I use to make sure that all of my deployments are signed and verified before release. This is an example of something I built out for a client actually just a few weeks ago. I'll walk through kind of the process here. This is where code is getting committed to their GitHub repository. And there's a GitHub Actions here. And the GitHub Actions is what creates the first receipt. It is part of Tekton, and it's what we call a pipeline run. And that is an infrastructure as code file that just gives instructions to Tekton over here in Kubernetes. By the way, Openshift is the Red Hat flavor of Kubernetes. So if you see Openshift, it's just interchangeable with Kubernetes. So it creates that artifact, that signed artifact, that then lets Kubernetes know that it needs to start building. It needs to start building the code and building the image that'll be used for this deployment. So there's a variety of different steps that happen here where the code is moved around a bit. It builds here in this DevOps namespace. And then Tekton chains will come and then generate that signed image, which is added to a registry in this case. This registry supports Sigstore. There's a few different variations of assets. So you have signing that can be just specifically for images, and you have signing that can be for different types of assets as well. So Sigstore actually can encompass a few different types of artifacts here along the process. And then ultimately, once this is done, it lets the system know that it can deploy this code. But because of Kyverno up here and the monitoring that's doing, it must verify that that image appropriately came from this container registry and this signed store. So that gives you an idea of the whole process. Like I said, there's a lot of nuances here where different artifacts can cause different variations of this, but this kind of gives you the overall view of, especially for Kubernetes, how we handle this secure zero trust supply chain. All right, I'm going to show a demo. Unfortunately, I don't know if anyone watches cooking shows, but sometimes they'll be doing the cooking and then all of a sudden they pull out like what was done because they didn't have time to cook it. In my case, for some reason, my Kubernetes cluster is being blocked by GitHub. Now I do have this ran earlier successfully, so I'm going to kind of outline, but there might be a thing there that says error, so don't just ignore that. So this is what Openshift looks like. This is the UI. I typically don't use the UI because I'm more comfortable with the command line, but I wanted to show you this because it's a lot easier to show everyone. And here, if I go into this Hello Chris environment, look at workloads, and I go to pods, you'll see my applications running here. This is what's not working right now. This is the Tecton, which is launching and trying to actually run this. But thankfully, I had it actually successfully run earlier. I am going to come over here and bear with me. Like I said, I usually do this over the CLI. And give me a moment. There we go. Need to find this. So this pipeline run file here, and I'll show you what this looks like. Kind of like what I was talking about earlier, everything in Kubernetes is infrastructure as code. This means that everything at the end of the day is a file. So this is very similar to how Linux works. So really everything at the end of the day is a file that you can either directly access or the system or the kernel is accessing. And this is the same for Kubernetes, where even to run a CICD process, you have to create a file. And this is the one that was created for this. And I'm sorry that's not coming up the best. 1 second, I'm going to switch over, make this a little bit easier for everybody to see. I'm going to switch this over to my my CLI. Bear with me a moment. Okay, this is my sweet spot. This is what I do day to day. So right now I'm in that same project that you saw earlier. For some of you more familiar with containers or Kubernetes, this is also a namespace. So right now I'm in the Hello Chris namespace. Right now the application is up and running from an earlier build. That's this top one right here. And then the build that I ran, unfortunately, didn't run successfully. But I still want to show you the assets that came from that, because it's really not the build process that's important. It's the signing that's important. So earlier I showed you that pipeline run. And here you see it failed. But like I said earlier, I had one actually succeed. And when you run these pipeline runs, something else is created called a task run. And if I show you that infrastructure as code definition of this guy, you'll see here that I have somewhere here, I have the Tecton signature. Yeah, here. So this right here is one of those hashes I was talking about. So in the labeling of all of these resources, there's going to be a hash provided here. You see there's a lot of other metadata here too to help be able to work through this. But here is probably the most important. we have this hash here that's been applied. And then if I go back to the pipeline run, there's going to be one here too. This one's actually going to have the full signature. Yep. So this whole thing right here is the chains.tecton signature pipeline run. So this actually ultimately is what we would go back to verify. This is the public key that we would then verify with the private key that Tecton chains is storing. Or you could also just have Sigstore store to make sure that you've appropriately signed this deployment as it's before it's going out to like a production environment. Now, this also signs artifacts. I'll need to switch back to where I was before. And I know we're coming up on time here, so I'll wrap this up quickly. And then I just want to show you one more thing here. This is my container registry. This is Quay.com, Quay.io, which is Red Hat's public registry. And you'll see here, I have the Hello Chris image. And then what's important here are all these different ATT and SIG files. So these are my signatures then for the image. So these are the public signed signatures. And this is also what Kyverno then verifies that is present with the application. So when this image right here is pulled down into the cluster, it will then also pull these two files down with it. Actually, I think it's these top two, and then verify that those signatures are correct. So these are some of the tools I'm using day to day to solve this problem. There's a lot of focus in this area, a lot of development going on. Things seem to change really on a weekly basis. But this gives you kind of a high-level overview of some of the core steps that at least I'm doing with different Fortune 500 companies and government agencies to help solve this problem that especially came out of the SolarWinds hack. And then with that, I am open for questions.
Okay, great. Hey, thanks a lot. So we are getting close on time here, and I know students have to get to other classes, but I'm going to look through the Q&A here and pick out a few of these. Let's see. So Gilberto asks, what are alternatives to Kubernetes? And I know you mentioned that OpenShift is kind of based on Kubernetes, right? But like others.
So of just vanilla Kubernetes, OpenShift is probably the most known. VMware has Tanzu, which is their own flavor of Kubernetes. But if you're looking for just a container orchestrator, which is not Kubernetes, Docker Swarm is probably the most popular. The ECS, Elastic Container Service on AWS is popular. It's not Kubernetes based. And then a lot of people will just run their containers on a VM running like Docker or Podman often. Pivotal Cloud Foundry was a big one, but they're switching their approach. I think they got bought out by VMware, and they're getting more merged with Tanzu. But those are some of the big ones out there. And also, Mesosphere, DCOS, is probably the other big industry leader in container orchestration that's not Kubernetes.
Okay. Drew asks, you touched briefly on migrating legacy applications into cloud native applications. What kind of common issues do you find when you're doing that?
First off, Google, just Google my name and Amsterdam KubeCon. I have a 50-minute presentation on that very subject. But with that, I'll touch on the highlights. The biggest thing is compliance. compliance derails migrations all the time, and it'll derail migrations that have had millions of dollars invested into them a year in. And I always say to people, who's not in the room on day one? It's almost always the compliance guy sitting in a corner on the other side of the building that no one knows about, and then he comes out and says, actually, you can't do any of this because these applications aren't permitted because of data gravity. Data gravity is a key term. Definitely look into it. That's based off of how are you able to move data up into the cloud? Are there certain like HIPAA requirements around it? Are there just technological requirements that are preventing it from moving up? But compliance is probably the biggest one. And then expectations within a whole organization. You know, if only one part of the organization is bought into a cloud migration, there's always butting heads with other groups at that point who find it to be more resistive to what they're trying to do. Like it's derailing a lot of their progress. So if you're not setting the benefits up with people within the whole organization, typically migrations will fall flat on their feet pretty early on.
Okay, we got a couple questions from Rahul. Let's see. The first one, well, he was asking about any suggested resources for certification in Red Hat. And, you know, maybe you can just put some in the chat, and also he's asking about Terraform, you know, attempting to use that for SecOps. Yes,
so Terraform is very good for when you're trying to deploy into a state that you will not, more than likely will not change, or you're deploying like that initial framework. What I always say is like Terraform and Ansible are very good if you're building a house. It's like the structure, it's like the foundation and like the walls, and then there's other tools on top of that that then are for like putting your furniture in place and putting all of your appliances in place, because those can actually change a little bit more than the structure. So that's where Terraform really shines. But Terraform likely cannot do from beginning to end. Usually you'll have tools like Tekton or GitOps that are then being incorporated on top of Ansible and Terraform to then get that final deployment of all of your different services that are required for your environment.
Cool. And so like suggestions for certification, like what would one
sure.
What would you recommend?
I would recommend the 180 and the 280 certifications of Red Hat. That's the Introduction to Containers certification, and then the 280 is the OpenShift Administrator certification. But there's also the Linux Foundation and the CNCF, which also have their own certs. They're far cheaper. Now, obviously, the Red Hat certs are going to take you very far in industry. There's some people who are going to require those. If you're just looking for something to learn and have something to verify that you've learned, I would definitely check the Cloud Native Computing Foundation, because they also have certifications that are very similar: Introduction to Containers, Introduction to Kubernetes, Introduction to Devsecops within Kubernetes, that are, like I said, much cheaper, and especially for students, there's really good discounts there as well.
Okay. And one last question, another one from Drew, asks if you've had a chance to check out the Phoenix project, and, you know, if it's an accurate representation of the problems you can solve with DevOps. Have you come across?
Oh yeah, the book. No, that's I assume he's talking about the book, the Phoenix project. Yes, I've read that book. I assume that's the one you're talking about. And it's a very good book to get introduced with DevOps. The only thing about it is that the last quarter of it, I think it's a little opinionated and sales-ish. They're definitely giving you a pitch for, you know, hiring their consulting services and their technologies. However, the first 3/4 of it is excellent, and how it's very often how I even approach customers when I'm doing this digital transformation or cloud native modernization, where, you know, you're having to take it like kind of one step at a time and be very iterative, and also set those expectations within the whole organization rather than just a subset of the organization. It's a wonderful book. I would definitely recommend everyone check it out if you're going into the area of DevOps. or infra or anywhere that you're going to be interfacing a lot with those methodologies.
Okay, yeah, I see that. I just Googled it. Yeah, look back 2013. It's a novel. So
yep. There's a new one too, and I'm sorry, the name of it is escaping me, but a couple of the authors of that book have a new one that came out last year. Like I said, I'm very sorry, the name's escaping me right now, but it's kind of a continuation of that book, and it goes off of a lot of the newer, some of the more modern issues, because that book was very early on in the DevOps area. Not as much cloud native work was going on. The new version of it has a lot of cloud native focus. And yeah, unfortunately, I'm trying to see if it's on my shelf. I own it, but I don't see it there. So unfortunately, just look around a couple of the authors. Like I said, 2 of them co-authored the new book, and I would definitely check it out if you have an opportunity.
yeah, I see one of the authors is Gene Kim, who I know has ties to Purdue in the past with Professor Spafford here
Yep.
and the software tripwire. So that's awesome. That's cool. Okay, that's it. That's all the questions. Thank you so much. Really appreciate it. This is a very timely talk here, and learned a lot of stuff myself here. So yeah, definitely. I know you're kind of close in town here, so feel free to stop by CERIAS whenever you get a chance. We'd love to have you.
Yeah, definitely know if you want me back. There's a few more. If any of these subjects interest people, I could definitely do more of a deep dive into one area. But yeah, thank you so much for having me.
All right, great. Thanks a lot, Christopher. Take care.
Yep, everyone have a great day.
Bye.